Okay, picking up where we left off at, we would change this 1 to a to the 0 power. Now we have the same base, and we would subtract the exponents. We would have 0 minus a negative 4, which would give us 0 plus 4. So we would end up with a to the 4th power, divided by 1. So our final answer would just be a to the 4th power. Now, with this rule, we have 1 over b to the negative n. You know, b stands for your base. So what happens is you have your base and your exponent becomes positive. And that is your final answer. Now, it says note, moving a factor across the fraction bar in either directions changes the sign of the exponent. Definition: expressions containing exponents are considered simplified when all parentheses are removed, factors with like bases are combined, and all bases have positive exponents. So that means you cannot have an answer that has a negative exponent. Now, let's take a look here. We have 8 to the negative 2 power. Now we have our base taken to a negative exponent, so we know we will put 1 over. Our base will remain the same. Our exponent will become positive. And we will have 1 over 8 to the 2nd power is 64. Now we go to b. We had 3 to the negative 3 power, and we had 2 to the negative 4 power. Now, what we could do is this here. Since we know that this 3 to the negative 3 will end up in your denominator, and this 2 to the negative 4 will end up in your numerator, all we would do is just switch what position they have. So this 2 to the negative 4 will go up in the numerator as 2 to the 4th power. This 3 to the negative 3 will go in the denominator as 3 to the positive 3 power. And this would give us 16 over 27. Now, let's take a look here at C. We have 2x to the negative 5th, y to the 3rd. So we will have 2, y to the 3rd, and your x will go in the denominator as x to the 5th power. And that's it. Now, with D, we have negative 8, x to the negative 13th power. So it'll be negative 8 will remain in your numerator. X to the negative 13 will go in your denominator as a positive x to the 13th power. So this is your final answer. Now there's one other thing I want you to note up here in B. Let's say that this was not negative 3 in your numerator. Let's say this was 3 to the 3rd over 2 to the negative 4. Now, we would bring this 2 to the negative 4 into your numerator. So 3 to the 3rd would stay in your numerator. And then 2 to the 4th will move up to your numerator. And since there was nothing left in your denominator, it will be 1. Now, 3 to the 3rd, we know we will end up with 27 times 16 all over 1. And we could just take 27 times 16, which will equal 432. And we don't have to put it over 1. Now, as you see, there's a distinct difference here. See, these two shifted places because both were negative. But since this was the only one that was negative, this is the only one that shifted its place. So now, we move on. We have example 5. It says simplify it completely. Now, we have 21 m to the 3rd n to the negative 2 over 7 m to the negative 5 n to the 3rd. Now we know 21 divided by 7, we know that would give us 3. 3 will remain in our numerator. Now we have m to the 3rd over m to the negative 5. Now we know we will leave the m to the 3rd in our numerator. This m to the negative 5 will come up to our numerator as well. Now we have n to the negative 2 over n to the 3rd. So we know n to the negative 2 will go in our denominator as n to the positive 2, and we will still have our n to the 3rd. So now we have 3. M to the 3rd times m to the 5th is m to the 8th. N to the 2nd times n to the 3rd is n to the 5th. and that is our final answer. Now we go here to B. We have 6x to the negative 3 to the negative 2. Now remember, I told you when you have a power to a power, you multiply. But this 6 here would be 6 to the negative 2 power. And then we have x to the negative 3 to the negative 2. So negative 3 times negative 2 is a positive 6. So we will have x to the 6 in our numerator. This 6 to the negative 2 goes in the denominator as 6 to the positive 2 power. And our final answer would be x to the 6 over 36. Now we go here to C. Now if you notice here, this whole parenthesis is taken to the negative 3rd power, and this whole parenthesis here is taken to the 2nd power. So what this means is this here. This whole parenthesis here is going to go in the denominator. Or you know what? No. Let's do this. We'll just make this 2 to the negative 3. And then x to the negative 4 to the negative 3rd is x to the 12th. And y to the negative 3rd we know is y to the negative 3. Now in our denominator, this will be 4 squared. This will be x to the 4th. And this will be y to the negative 10. Now, 2 to the negative 3, we know that will go in our denominator. So far we had 2 to the 3rd power times 4 squared. And then we will be left with the x to the 12th. And then, you know, this y to the 3rd will go down to the bottom of your fraction as well. So we'll write this x to the 4th. And then we will have our y to the 3rd. And this y to the negative 10 will go up into your numerator. So we have x to the 12th, y to the 10th, all over 2 to the 3rd is 8, 4 to the 2nd is 16, and then we will have x to the 4th, y to the 3rd. Now, x to the 12th divided by x to the 4th, we know we will subtract those exponents. 12 minus 4 is 8, so this will give us x to the 8th. Y to the 10th divided by y to the 3rd, we know we will subtract the exponents. 10 minus 3 is 7, so it'll be y to the 7th. And then finally, 8 times 16 will give us 128. And that will be it. Now we come here to D. Now we have two parentheses that are multiplied to each other. So we need to multiply these parentheses and then simplify. So 16 times 25 is actually 400. A to the negative 2 times a to the 4th. We will add the exponents. That will give us a to the 2nd power. And b times b to the 5th. Remember, this b is assumed to be taken to the 1st power. 1 plus a negative 5 is a negative 4. So that gives us b to the negative 4. Now we go in our denominator. 15 times 8 will give us 120. A to the 5th times a to the negative 7. We add the exponents. That will give us a to the negative 2. Next we have our b's. B to the negative 1 times b to the negative 2 will give us b to the negative 3. Now we want to simplify. Now first we would start with the 400 and the 120. Both of them have 40 in common. So we could divide both by 40, and this will leave us 10 over 3. Now we look at our exponents. We have a to the 2nd and a to the negative 2. That's the same as saying a to the 2nd minus a negative 2. Because remember, we would take, they have the same base, we subtract the exponents. Now we come to our b's. We could shift these b's. That means that b to the 3rd would be in our numerator and b to the 4th would be in our denominator. Now, we will have 10 a to the fourth, and then we would end up with b to the negative 1 all over 3. Because we know 3 minus 4 would give us negative 1. And since we add this b to the negative 1, we know that that b goes in our denominator. So we add 10a to the fourth all over b. You don't have to write b to the first power. You could just leave it. That's just b. Okay, now we have exponential function. A function in the form f of x is equal to ab to the x, where a is not equal to 0 and b is greater than 0 and b is not equal to 1. The constant b is called the base. It says let h of x is equal to 5 times 4 to the x. Find the following. So what we need to do here, we need to take this 2 and substitute in for every place that x occurs. So we will have h of 2 is equal to 5 times 4 to the second power. We substitute in 2 wherever x occurred. So now we will have 5 times 16. And 5 times 16 we know is 80. So that is our final answer. Now we have h to the negative 3. We do the same thing here. We will substitute in. We will have h to the negative 3 is equal to 5 times 4 to the negative 3. So we have h of negative 3 is equal to 5 times, we know 4 to the negative 3 will give us 1 over 4 cubed, which is the same thing as 5 over 4 to the third power, because 5 times 1 over 4 cubed is 5 over 4 to the third power, which is equal to 5 over 64. Now, remember back in chapters 1 through 3, we had what our notes had said about linear functions, which meant that f of x is basically equal to what we would call the slope-intercept form, which is mx plus b. And that is basically what we did down here. Okay, now we come to scientific notation. It's a number expressed in the form a times 10 to the k, where 1 is less than or equal to the absolute value of a, which is less than 10. And n is an integer. Calculators use e to stand for times 10 to whatever power. Positive values of k correspond to big numbers. Negative values of k correspond to small numbers. Okay, now it says write the number in standard decimal notation. You have 4.8 times 10 to the 7th power. That means that you move this decimal 7 places to the right. So it'll be 4800. So we will have, let's see here, we will end up with 48 million. That will be your final answer. Now in your calculator, if you were to type this in, it will come up like this here. It will come up as 4.8 E7. This means this. And you can type this in your calculator and you will see this. But this right here is what will show up in your calculator, this E7. So we had negative 4.8 E7. We still would move this to the right 7 places. So it'll be negative 4, 8, and then 6 more zeros. And this would be our answer, negative 48 million. Now we come here. We had 2.019 times 10 to the negative 3. That means we move to the left 3 places. So then that will leave us 0.00